Welcome back. 11th problem 11, integral negative 9 over square root t squared minus 6t plus 13 dt. So we need to simplify this. It's going to be some kind of complete square, right? So square root of t squared minus 6t plus 13 is t squared minus 6t. Complete it as a square by adding 9, subtracting 9 plus 13. So that's nothing but plus 4. So this quantity squared plus 4. You can call this a new variable u. U is t minus 3. Then du is simply dt and t itself is u plus 3. So our original integral now is negative 9 over square root u squared plus 4. Plus 4 tells me it's going to be a tan. 2 tan theta. U is 2 tan theta. Du is then 2 secant squared theta d theta. Okay, d theta is missing there. Du is 2 secant squared theta d theta. Radical u squared plus 4 is radical 4 tan squared plus 4. Notice by now you're probably aware this is all going to be 2 secant theta. So this integral is negative 9 du square root u squared plus 4, which in turn is negative 9 over 2 secant theta, 2 secant square theta d theta. So 2 cancels 2, secant cancels one of the secants. You're left with negative 9 integral secant theta. Negative 9 integral of secant is natural log of absolute value secant theta plus tan theta plus some constant. Secant theta itself is this expression over 2. Tan theta itself is u over 2. So notice you have a common denominator, correct? So natural log will be of the numerator minus of the denominator. So minus and a minus. So that's where this comes from. So notice this is a pure constant. This constant plus your original constant of integration will be some other constant of integration. So we have simply rewritten this with some c. Replace u by t. Remember the question was in terms of t. This entire expression was going to be u squared plus 4. So all of that is the entire expression inside. U itself is t minus 3 and that's your final answer. So let's try. Negative 9 natural log absolute value square root t power 2 minus 6 times t plus 13, that's in the square root, plus parenthesis t minus 3 absolute value plus constant of integration. Check. Correct. Next problem. So this is the last problem. Integral x squared over x squared plus a squared 3 power of 3 halves. A is some constant, but plus a squared tells me I'm going to use tan with a as the multiple. So x equals, right? X equals a tan theta. Dx then is a secant square theta d theta. So what happens to my expression here? X squared is a squared tan squared plus a squared. So a squared is common. Tan squared plus 1 is secant squared. So that's what happens to my input inside power 3 halves. So notice square and the power half, they cancel. All I'm left with is power 3, a cubed secant cubed. So the denominator is a cubed secant cubed. Numerator is a squared tan squared. So a squared tan squared over a cubed secant cube, and dx itself is a secant square theta d theta. So fantastic. Now all I'm doing is a, they all cancel. You see a cube upstairs, a cube downstairs. The rest of it, when you convert everything to sines, cosine, this is what I am left with. Okay. I'm not cancelling this with this. Okay. So, okay, now I have cancelled it, but what happens to sine squared? It is 1 minus cosine squared. This is good because I can simply divide this. 1 over cosine is secant, cosine squared over cosine is cosine. Integral of secant is natural log absolute value secant plus tan. Integral of cosine is sine plus some constant. Now what was secant? Secant here, right? So all of this inside is a squared secant squared. So if I want secant, I don't want power 3/2 and so on. All I need is square root. So square root of this quantity over a, that is secant. And tan is x over a. That's all we have done. All right. Minus sine. What is sine? Sine is tan over secant. So I have written it in this fashion because I know the expression for sine and secant. So what I do is I write the expression of tan that has an x above and secant that has the radical expression below. Natural log, on the other hand, because I have a common denominator, I can take it away, negative natural log. That's pure number. When a is a fixed number, this is a constant. Along with that constant of integration from above, you get a new constant of integration below. So natural log of absolute value of this entire expression and this fraction with a negative plus a constant of integration. So let's try. Natural log of absolute value square root x to the power 2 plus a to the power 2, get out of the square root, plus x absolute value. Now it's a minus x over square root x to the power 2 plus a to the power 2, and get out of the radical constant of integration. Okay, it's correct, and that was your last problem. This completes section 7.3. We'll continue next section in our next video. Until then,